students. So this is the third video under calculus playlist. In the previous video, I have explained how to find the length of the arc of a given Cartesian curve. So in this video, second application, how to compute the area of a plane region R. So under application of single integral, it is second one. So the idea is that if y is equal to f of x, this is a Cartesian curve. In two dimensions, in 2D, two dimensions. In sense, so we can consider a graph of such curve this is your Cartesian curve. Because the two arrows indicate that the curve is infinite, unbounded in both directions, we will take only a portion of it, running from x equal to small a to x equal to small b. These are the equations of the respective parallel lines. So this is the plane region formed. Between the curve, the axis, and the boundaries. So here we find 4 boundaries. We can write R for region. R stands for plane region. Bounded by first one, this boundary, y is equal to f of x. Number 2, left side, x equal to a. Number 3, x-axis. Number 4, x equal to b. So to find that area bounded by these 4 boundaries of this region, we are going to take a rectangle, a random rectangle inside that region. So I'll show you separately. This rectangle, suppose we considered inside that R, this portion is small width because we are taking along the x-axis, the width is dx units, and this is your height or length, you can say height of the function, height that is equal to the given by f of x is equal to y equal to y. We will take the width such a small part so that the height more or less becomes a straight line connecting the x-axis and the curve. So imagine it is a thin rectangle whose width is dx and the height is almost equal to the value of the function y for a given value of x here. So we can take it is the height of the function given to you from that Cartesian equation. Starting from x equal to a to x equal to b, you construct such rectangles, vertical rectangles, find their area, the area of small area, we can write dA, length into breadth, or you can say height into width. Height into width, in this sense, here height is the y value and width is dx. Like that, if you add all those areas of each small rectangle, vertical rectangles, starting from x equal to a to x equal to b, we will get the complete area of the region R bounded by these four boundaries. So integrating means adding all those areas from x is equal to a to x equal to b. We get integration from a to b y dx, which implies computing the areas of each vertical rectangle, we are going to get the area of the region R. So the formula to compute area of a plane region is given by integral from a to b y dx unit square. This is the idea behind the application of a single integral, finding the area of a plane region R. We shall see one problem, how we can able to work out this. Let us continue. So this problem will be clear to you to compute that the area of the plane region. So compute the area of the plane region capital R bounded by means how the region R is formed. Y equal to x square, it is the portion of the curve. X equal to 0, that is the equation of y axis. X equal to 4, line parallel to y axis, and the x axis. And the x axis using definite integral or simply the line integral, or we can say the single integral, whatever you can use it. So you follow these steps to work out such problems. First, what is given to you? Given that, just from the given problem only, you are going to state R is the plane region bounded by y is equal to x square. It is also called a parabola, a curve portion. Number 2, x equal to 0. It is nothing but your y-axis, equation of y-axis. Third one, x equal to 4. It is a line parallel to y-axis. Number 4, the x-axis. The x-axis. You can show its equation is y equal to 0. Y equal to 0. Second, give the sketch of R. How that region R is formed with the help of these four boundaries, you have to show there. It's very simple. You can take the coordinate axis. There is x-axis, y-axis, origin. So y is equal to x square. It's a parabola whose branches will be one on right hand side, one on left hand side. So this is a branch we can consider. Y is equal to x square, one boundary. and the equation of y axis is x equal to 0 and equation of x axis is y equal to 0. You see that all are clearly labeled in the graph. It is done. Next, x equal to 4. So 4 units away from the origin, it is your 4 comma 0. The equation is parallel to y-axis, x equal to 4. Right? So 1, 2, 3, because x equal to 0 is just a point near the origin. So here we got a 3 bounded region R. Though it is showing 4, it is only 3, obviously it is very coincident. So this is a region, shade in red color, we need to find the area. And this point we can denote it by 0, 0, 0, 0. So we have to find that area using that definite integral. What is 3-step procedure? Just a given thing, give the sketch and use the definite integral to compute that area. So area of that region is given by integrating from x equal to a to x equal to v y dx unit square. Here a is equal to 0, b equal to 4. b equal to 4. So it is 0 to 4, x square, y is x square, dx. It is very simple integral, x power 3 by 3, limits from 0 to 4. So 1 over 3, 4 cube minus 0 cube, that is 64 by 3 unit square. Like this, you need to compute that area of the region. So first point is that write down that region R, how it is bounded. You mention the boundaries. Then give the rough sketch showing all the boundaries of the region R. Shade the region R to be computed the area. Then use the definite integral or single integral to find out the area of the region of any given Cartesian curve like this. Hope this video is very clear to you, and do practice the problems from your text, whatever you are following from the calculus, by this idea what I have showed. Share our video, subscribe our channel, and communicate this information to your friends, and post your comments regarding queries to get clarified. All the best.